Hello, and welcome to Training with Trisonius. I am Trisonius. Today, for Lesson 9, we are going to be revisiting methods and taking a slightly deeper dive into the power of methods. So, without further ado, let's get started. So what will we learn today? Well, we're going to learn about a very important concept called access specifiers. Access specifiers are key to the implementation of encapsulation within C#. And so we'll get into the whole concept of encapsulation and polymorphism and inheritance and all the object-oriented stuff a little bit later, but we're building towards that. And so it's important we understand access specifiers. We also want to learn about return types. So to date, every method that we've written performs some action, but it's always of type void, meaning that it doesn't return a value. But you can actually define your methods to return values. And so we'll talk about return types. Finally, we'll talk about parameters. Parameters enable you to pass information or data into a method to be used by that method. We'll explain why that's important and what the different types of parameters are. As you can see here on the screen, there's three types that are defined: value parameters, reference parameters, and output parameters. We're also going to talk about optional parameters that have a default value. Okay, so let's go ahead and jump right into the code. Oh, by the way, we're going to change the format of our lessons going forward. I've received some feedback that maybe they're a little bit too long and dull based on the detail that I'm going into. So we're going to change that format up slightly so that we'll always go define what we're going to learn, but then we'll jump straight into Visual Studio and begin to develop. And I'll show you these new concepts in code and talk to you there instead of just talking to text on the screen. And then we'll wrap up with a review of what it is that we've learned. Okay, so without further ado, let's get into the code. Okay, welcome to Visual Studio. I've already opened it. And we're going to do like we did in our last lesson. We're going to create a new project. So let's go to Console App for the .NET Framework. Let's create a new project. I'm going to name this project Methods Revisited. And we'll create that. And what we're going to be doing is we're going to be learning about access specifiers, and we're going to be learning more about methods. And I want a separate project to be able to show you this. And soon we'll be getting back to our game, but there's just a few things that we need to learn first. So what I'm going to do is I'm going to declare a variable. We're going to declare a variable of type string, and we'll name it character name. So we now have a string that we've named character name. And when we define string character name, by default it is private, meaning that nothing outside of the class program can see it. Now anything inside of class program can see it because we've declared it at the very top of the class. But nothing below, nothing outside, I should say, of class can see it because by default it's private. Now we can type the keyword private here. By default, if you don't type one, it is private. But private is an access specifier. And it states that this data, character name of type string, is private to the class program. and nothing outside of class can see it. So we could make this public. If we made it public, now anything outside of class program can see it. Now I know that may not make a lot of sense to you right now. You may say, well, what's the purpose of making something private and public? And well, once we start working more with classes, building custom classes, this will make perfect sense to you. However, right now, I just want to introduce the concept. And I know that you may not fully be able to grasp it, but you will later on. But the concept is you can define by using these access specifiers the level of access that's allowed to this data by something outside of this class. Now you could also use protected. Now the protected keyword, it basically treats this as though it were private. And so nothing outside of this class can see this data. However, if you have another class inherit this class, then the protected data will be the same as private. It'll be as if it were declared within the parent class as, or within the derived class as private. So again, we will get into classes later and that'll make more sense. You can also define something as internal. If you define it as internal, what that means is that anything within the solution can see it. So anything within the solution can see it, but anything outside of the solution cannot. And so, hope that makes sense. And again, access specifiers are exactly that. How do we control access to the data? And here you're saying I'll allow anything that's part of the methods revisited solution to be able to see this. But if you're not part of the methods revisited solution, you cannot see it. And finally, we can add protected and internal together. When we do this, remember, protected allows, if a class inherits, another class inherits this class, it can see this data as though it were private. And internal limits access to only other classes that are within the same solution. So protected internal will allow only other classes that are part of the methods revisited solution that are inheriting this particular class to see this data as though it were private. Okay. Again, this will make more sense later. But I have to introduce these concepts at some point in time, and now is as good a time as any. So we're going to go ahead and make this private, meaning that anything inside of class program can see it. So what I want to do is I want to go and create a new method. So let's create a new method, and we're going to call this method, we're going to make it private. Private void get name. And so here it has an access specifier of private, meaning that nothing outside of this class can see it. It's private outside. And so only the things inside the class have access to it. Void means that it does not return. Using the void keyword means it does not return a value. And so get name as a method, and this is how you've learned to call these so far, is just void get name or private void get name. And we could set a name like character name equals Trisonius. Then anytime that we call getName method, it will set the character name to Trisonius. Now the reason that we can see character name is because we declared it as a global variable. Remember we talked about this in an earlier lesson? We declared it as a global variable up here, so everything in this class can see character name. If, however, and I'll show you this, let's get rid of private. If you declare a variable within a method, you do not use access specifiers, because variables declared inside of a method are already private, and only things inside of that method can see them. So let's delete this. Let's put this inside of here. So there you go. Look, we've got this declared. A variable declared. This has a green line under it saying, hey, the variable character name is declared but never used. Well, wait a second. It's being used right here. But this says, hey, the name character name does not exist in the current context. Well, the reason why is this method cannot see a variable declared within this method. So when you declare a variable, anything that's a child, so if you declare it in the class, any method in the class can see it. But if you declare it within a method, only that one method can see it. In fact, if you declare a variable in a block, that means any block of code designated between brackets, only items that exist within that same block can see that variable. So if we had, so here we've got character name. And let's just go ahead and set character name equal to, we'll just Todd. How about that? So now we've assigned a character to Todd, or name, sorry, the name Todd to character name. And then we can do a console.writeLine, and we can write out the value of character name. And now the green line goes away. So this method is using the variable character name just fine. However, this method can't see it because it was not declared within the block of code that was the parent for this. So it can only see variables that are declared in the block, which is the parent of a block of code, or if it's declared within the block itself. So again, if I take this and I delete it from here, we're going to see something funny happen here in just a second. Not funny, but and I declare it up here, you see that now this can see it. Well, that's interesting. Well, why can't this see it? This says it doesn't exist. Well, the reason that this can't see it is because this is a static method. Static methods can only see other static items. So a static method can see static variables or static methods, but it can't see non-static entities. So if I were to make this a static string, suddenly this can see it. Now regular methods can see both static and locally defined or non-static variables. Okay. So now finally we have static string character name, and that's great. Now what if we wanted to have a method that returned a value? That would be fantastic. So what if we, instead of defining it this way, we could change getName to actually be of type string. What that means is that it must return a string. And so we could just simply come in here and type return Trisonius, and then getName will now return the string Trisonius anytime it's called. So anytime you call getName, it's going to return a value. So you're going to want to make something equal to getName to capture that value. So down here, we could, instead of typing that, we could type getName. Oh, but look, it doesn't see it. Why doesn't it see it? Remember, this is a static void. It can only see other things that are static. Interesting. So let's make that static. And now suddenly it can see it. Now, if we were to run this program, it would write Trisonius to the screen. And so let's go ahead and go to debug, start without debugging, and you'll see that it writes the word or name Trisonius to the screen. Trisonius. Okay, it wrote that because we said let's call getName. When we call getName, the flow jumps down here. The process flow jumps down here and executes this code. It executes the getName method. Well, the getName method returns Trisonius. So if getName returns Trisonius, then we're going to take whatever getName returned and assign it to character name. Remember, this is an assignment operator. So we're going to assign that to character name, which means that character name now contains the word Trisonius, or the name Trisonius. And then when we write that line out, it prints out our name, Trisonius. Hope that makes sense. Okay, let's learn something else. Let's do something else. Are you ready? Let's learn about parameters. So we know return types. Well, you know what? Let's create another method first, just to show you. Private, static. This one's going to return a number. We're going to call this get age. How about that? And you can also declare a variable inside of a method and then return that variable. So here I'll declare a variable of type integer. We'll call it age. And you know what? I'll just initialize that to a value of 17. And then we will return age. So now we have another method called getAge, and it returns a number. So I could come up here and declare a variable called age and make it equal to getAge. And you may say, well, wait a second. How were you able to declare a variable called age? You already have one down here. But remember, this is declared within this block of code. So nothing outside of this block of code can see it. So I can use the same name in this block of code. So here we have an integer named age. So we're going to take whatever getAge returns and assign it to the age variable. And what I will do is I will write another console.writeLine, and we will have it print out age. Now if we go and run this, we'll see Trisonius and age. Very good. And you know, I could put, how about I put name, colon, and then we'll put age, colon. And that way it prints out a little bit better. So we debug that again, and we can see now, oh well, sorry, I need to start without debugging. We can see the name is Trisonius and age is 17. Interestingly enough, we've not defined the name or the age inside of this method at all. Those were defined in these methods and then returned. So all we're doing is just calling these methods to get the value. So that's pretty neat that you can actually have a method that can return a value as well. Okay, so let's talk about parameters. So what if I wanted to pass in the name? Well, if I wanted to pass in a name, I could come here and I could type in a parameter. And I could type in string, and I'm going to pass in the name. Well, I'm going to call this name. I'm just going to call it name. So you declare a variable here, basically, what data type and what name you want to reference or refer to it as. And this is called a parameter. Now, anytime that we call getName, you notice the red line, squiggly line up here, because we've changed this. Anytime that we call getName, we must pass a string to this method that represents the name that we want it to use. So I could just change this to name. So what that means is we're going to pass a name into the getName method, and then it's going to take and return that back out to us. So if I come up here to getName, and you notice if I mouse over it, it says there is no argument given that corresponds to the required formal parameter name. So we're not passing anything in. Parameters are defined within the parentheses of a method, and they define the data that's expected. An argument is the data that's being passed into a parameter. And the reason it's called an argument is because that data is interrogated to make sure that it's of the same type and meets the needs of the parameter. And so an argument is passed in. So in this case, if I change this to be Todd, now we're passing a string in to getName. And so when we pass that string in to getName, that gets put into this name variable. And then that's what will be returned. So if we run this again, it's going to say Todd. So Todd and 17. Okay, so this is a parameter. And you could put multiple parameters in here. In fact, you could put, what if we changed this to get character? And inside of here we pass in string, we pass in profession, we pass in race. Then what we could do is we could declare a variable called description. And we could make this description equals name is a profession of lineage. There we go. So we'll just description, and then we'll have this return description. Okay, so now I want to change this slightly. Let's get rid of this. So now we've got 3 parameters, and I'm not going to use character name anymore. We'll leave that up there, but I'm going to just declare a variable here called character description, if I can spell, description equals get character Trisonius, and you notice it says it requires, see right here, requires a string which is name, a string which is profession, and a string which is race. So we define Trisonius. We define, we'll make knight, and we'll say dwarven. How about that? All right. So now I'm going to have this just simply say description, and we'll have it print out character description. Okay. I'll scoot that over so it's lined up because I'm weird that way. All right, so here, get character, we're passing in Trisonius, knight, dwarven. Get character defines a variable called description. It makes description equal to the name plus a string is a plus the profession name plus of oops, sorry, this needs to be race. There we go. Now that makes more sense. Sorry, I forgot my race. So now, if I were to run this, and start without debugging, it says Trisonius is a knight of dwarven lineage. Oh, it gave me a description. Because I passed in Trisonius, I passed in the profession, I passed in the race. And down here I took the name, I added it to this string. And so I could pass in anything. I could pass in Donnie is mage and human. And then go back up here and run it. And it says Donnie is a mage of human lineage. That's pretty cool, huh? So all we're doing is passing in data to fulfill these parameters. Now, by default, when we pass parameters in, they're passed in by what's known as value. They're passed in by value, which means that we're taking a copy of Donnie and we're putting it into each one of these. So let's say that we had a string already defined for name. Let's just come up here and put static string name. And let's initialize this to Sylvia. How about that? And then instead of passing in Donnie, we're going to pass in, we're just going to pass in name. You see? We're going to pass in name. What I'm going to do is I'm going to actually make this a capital N so it doesn't conflict with this here. So we're going to pass in name, and that way capital N name will not be the same as lowercase name. So we've got a name called Sylvia. Now when we pass this in, Sylvia is a copy, right? It's a copy. So we're taking a copy of the value Sylvia, and that's what we're passing in. we're not actually passing in, even though we're referencing the variable, we're not actually passing in the memory location or address. We're passing in the actual value that's stored. So that means that any change that we make in this method, or in this method here, to name, only happens in this method. It doesn't affect the original at all. So it does not affect the original. And so here's what we're going to do. I'll prove that it's not going to affect the original. So I'm going to write out console original name, and we'll display name with a capital M, right? And we know that that is Sylvia. Okay. So I'm going to go ahead and get rid of character name here. You guys bear with me. This is called by value passing. And by default, that's what it is. It's by value. So if we go to debug and we start without debugging, we're going to see that Sylvia is a mage of human lineage. Great. And the original name is Sylvia. So that's fantastic. Well, what if we passed in name, right? And then we decided that we wanted to change name to Trisonius Ventrix. Okay. So we're going to pass in Sylvia, but we're going to change what we passed in to Trisonius Ventrix. Okay. So let's go ahead and run this. And what you're going to see is that we changed it to Trisonius Ventrix, but the original name remains Sylvia. Why did the original name remain Sylvia? Well, the reason why is because, again, we passed a copy of Sylvia in to this method. So when we changed it, we only changed the copy. We changed the value in that copy to Trisonius Ventrix. We didn't change the original. And so this is called passing by ref. I'm sorry, passing by value. This is passing by value, and it's the default way that when you define parameters for a method, copies of the values get passed in. And so any changes that happen to them within the method do not affect the original value. You can see our original value was Sylvia. But if we pass by reference, that's the second type of way that you can define a parameter. You can pass by reference. And the way you pass something by reference is you put the word ref in front. Now, you not only have to put the word ref in front of the parameter, but you also have to put the word ref in front of the argument. And when you do, what reference means is that, oh, we're not going to pass a copy of this. Instead, we're going to pass the actual memory location of this in. So that means that any change that is made within this method actually does change the original, because we're not passing a copy, we're passing in the memory address to the original location in memory, to the original value. So any change we make now will change that original value. So we'll keep our same code. All we've done is just change this to ref. Okay, that's it. But by doing that, we're now passing this by reference. So let's go to debug and start without debugging. And you'll notice that the original name actually changed to Trisonius Ventrix. And the reason the original name changed to Trisonius Ventrix is because we did not pass a copy. So we passed in the name Sylvia, right? It came in here to name. So now anything that we do to name actually changes this name because we passed in a reference. So by setting our internal name to Trisonius ventrix, it has the same memory location as this name. So anything that we assign to it actually gets assigned here. Again, because we passed it by reference. I hope that makes sense. We can also pass a variable as an out parameter. You can define it as an out parameter. So we could type in out, and I'm going to type in, oh, you know what? Health. So we've defined an out parameter named health. Now, when you define a parameter that's an out parameter, you need to declare a variable. So what we're going to do is we're going to declare, oh, you know what? I forgot to tell what the type was. So it's an out int health. Sorry. So this is going to expect us to provide an argument that's an integer variable in. Any modification that gets made will get passed back out. So let's say that we declared a variable called current health. And what we're going to do is we're going to pass in out current health. Okay? And you use the word out here because you're defining that it's an out parameter, just like you use the word ref in both places. So now we've got an integer and current health that we're going to pass in. So what we're going to do is we're going to set health equal to 19. Okay. And then we're going to come down here and console.writeLine, and we're going to type in health plus current health. And so what's going to happen is we're going to pass in this empty variable, it's a type integer, into our getCharacter method. The getCharacter method is going to take that, receive it as a variable called health. We're then going to set health to 19. So when this method ends, it will send back not only the description, but it'll also send back current health because it's an out parameter, meaning we're going to send it back out. Which means that current health should have a value of 19 when this is over with. And we should write health to the screen, and it should be 19. So let's go ahead and go to debug. Start without debugging. And we'll see that we've got age. So Trisonius ventrix, a mage of human lineage, age 17. Original name is Trisonius ventrix. Remember, its original name is Trisonius ventrix because we passed that particular parameter by ref. We defined it by ref, and then we passed an argument by ref. And then health is 19 because this is an out parameter. Okay, so now you've seen an example of by value parameters. You've seen an example of by ref parameters, and you've seen an example of an out parameter. The next thing I want to show you is an optional parameter. So let's go ahead and change this back from ref and make it value. By value again. Now, I can define here in getCharacter, I can define up here, I can put Mohana, how about that? I can say that string name equals Mohana. By doing this, we're setting a default value. What that does is it makes this particular parameter optional. So if we don't pass in a name, it will use Mohana as the default. So, but if we do pass in a name, then it'll use whatever we pass in. So let's go ahead and keep this just like it is, and let's run it. Oh, sorry. It did not like... Oh, I apologize. I forgot. Once you define something as optional, all other parameters after it must also be optional. Interesting. What I'm going to do is, you know what? I'll go ahead and set each of these to have a value as well. We'll just make this fighter, and string race will make Elven. And then this out parameter, we'll define it as 19 in the event that doesn't like the fact that we're doing that at all. Okay. So what I'm going to do then is I'm going to your optional parameters have to appear after your other parameters. So we're going to put the out parameter first, and then the optional parameters where they have a default value, because you can't make an out parameter default. Okay. So, but now that we've changed the order here, you notice that up here we've got errors because we changed the order. So what I'll do is I'll change the order here as well. And so we want to send in name. We want to send in mage. And then we want to send in human. All right, so there we go. So now we're sending these arguments in the same order that the parameters appear. I hope that makes sense. Okay, so now if we run this, Trissonius Ventrix, a mage of human lineage. 17, original name is Sylvia, health is 19. So everything's still working. If I come up here and I decide that I do not want to send in, I don't want to send in anything other than this out parameter. Well, you know what? I don't want to send in human. Okay? I don't want to send in human. We're going to leave that off. And it's fine. We can leave it off because it's optional. Now, if we run this, Trissonius Ventrix is a mage of elven lineage. So you notice that it took the default value that we supplied for that parameter and used it since we did not provide an argument. So let's get rid of mage too. And it should say that we're a fighter. Let's run this again. So Trissonius Ventrix is a fighter of elven lineage. Okay, so that's all working. And finally, let's get rid of name. Let's just pass in our out parameter. And start without debugging. And what? Trissonius Ventrix is a fighter of elven lineage. Well, that's interesting. But that's because we have set it here. Let's get rid of that. Now let's run this again. And it should use our default. Mohana is a fighter of elven lineage. But again, our original name is still Sylvia. Okay, so we've learned quite a bit. We've learned about the access specifiers, and we've learned about parameters, and we've learned that methods can return values. So they can accept values and they can return values. You can have your return types, which is you just use the keyword return and then the type that you want to return, the actual values. But that value must be of the same data type as what you've defined that the method is going to return. We've also learned that you can return data using an out parameter. And you just declare a variable and you pass it into the out parameter and it will populate it and then you'll get it back. And then we've also learned that you can have as many different parameters as you'd like, and you can define them as default parameters, or what's known as an optional parameter, by setting a default value. But we also learned, and I had forgot this, that once you define an optional parameter, you need to make sure that every parameter after that also has an optional value. So once you use it, everything beyond that must use it as well. Okay, I hope that you have found this lesson to be useful, and we'll wrap up with the summary of what it is that we've learned. See you in just a minute. So, in review, we learned today that access specifiers, there are several different types of access specifiers. There's a public access specifier, and it allows a class to expose its member variables and member methods to external methods and objects. There's a private access specifier that allows a class to hide its member variables and member methods from external methods and objects. Protected allows a child class, which we'll get into child classes later when we get more into classes and object-oriented programming, which is coming. We're not far away from that. But this allows a child class to access the member variables and member methods of a base class. Internal allows a class to expose its member variables and member methods to other methods and objects within the same assembly, or you could think of it as within the same solution. And protected internal allows a class to hide its member variables and member methods from other objects and methods except a child class within the same solution. All right. We also learned that parameters can be used within a method. Parameters are optional, but when you do have them, they are enclosed between the parentheses of a method, and the parameters are used to pass and receive data to a method or from a method. So the parameter list, the list of parameters, also referred to as the signature of the method, refers to the type, order, and number of parameters defined as part of that method signature. And then finally, there are 3 ways that parameters can be defined within a method signature. You can define a parameter as a value parameter, and again, just remember that means that we've made a copy of the actual data and passed it into the method. So anything that happens to a value parameter happens within the method, but not to the original value because we passed in a copy. A reference parameter, that means that anything we do to the parameter within the method actually affects the original because we've passed the memory address of the original in. And then an output parameter. And an output parameter allows us to return data as an output from a method. And so it gives us a way of returning more than just the standard return type. We could return the return type from a method, but also return data from an output parameter as well. And then remember, we also reviewed optional And optional parameters are those that if you don't pass an argument to the parameter, there's a default value already assigned, and so it'll use the default value. Okay, you know what? I hope that you've enjoyed this lesson and you've learned a lot. And until next time, this is Trisonius signing off.